Welcome grade 11 chemistry students to your third lesson. This lesson is all about chemistry, so the basics of chemistry from grade 10. We're going to talk about it, go over it. It's going to be about 15 minutes or so. If you want to just read over the PowerPoints, you can. They're available for download underneath the review folder on the Schoology website. You can do that. But we're going to answer the question, what is chemistry today? So chemistry is the study of the composition, structure, and properties of matter and the changes it undergoes. Pretty much, it's just the study of matter and everything about it. So what is matter? Matter is anything that has mass and occupies space or volume, okay? That's kind of interchangeable there. Well, what is mass then? Well, mass is the measure of the amount of matter. So the more matter that you have, the more mass you will have. Mass is a little bit different than weight. So if you study physics, they'll talk about that, but we just have to know in chemistry it's the amount of matter. So one thing you may have covered in grade 10 and grade 9 is the particle theory. And pretty much it's a theory, but the theory goes like this. All matter is made up of tiny particles. Okay, so if you look at anything, it's made up of tiny little particles. All particles of one substance are the same, different substances are made of different particles. So a bar of gold is going to be made of different particles than a bar of silver. There's spaces between the particles. We learned last lesson that the atoms themselves are made of empty space. Well, there's huge spaces between these particles as well. So the particles themselves are always moving. The more energy the particles have, the faster they move. So in a hot object, the atoms themselves and molecules are moving quicker than a cold object is. And that's what you feel when you feel something cold. You're actually feeling the absence of movement in those molecules or atoms. So there's also attractive forces between particles, and these forces are stronger when the particles are closer together. So when particles or atoms are far apart, there's a very weak attraction, but when they're closer together, there's a very strong attraction. So as you know, there is 3 phases of matter. There's solid, liquid, and gas. And if you take a look at the atoms or molecules in each, you can see that in a solid, they're very closely together, liquid, they're farther apart, and gas, they're very far apart. So to turn a solid into a liquid or a gas, what you have to do is you have to add heat. And what happens is you actually break these they're called a special type of bond that holds these atoms together. And as they break apart, they move farther and farther apart. So solids, they have a definite volume and shape. Particles are packed in fixed positions. Liquids, you have a definite volume but an indefinite shape. Particles closer together but not in fixed positions. What this means is that if you have 100 milliliters of water in your glass right now, if you pour it into a different container, it will take the shape of the container, but it will still be 100 milliliters. Now, you can't do that with a solid as well. Now, the interesting thing is a gas has neither definite volume nor definite shape. So this means if you take a little bit of gas from a container, if you release it into a large room, that gas will occupy that volume of that whole room. So if you start with 100 milliliters of gas, essentially you can end up with a room full of gas from those initial 100 milliliters. The atoms or molecules are very spread apart. And the last thing that we have is something you probably never heard of. It's called a plasma. Now, a plasma is high temperature ionized phase of matter. It's found in the sun. I'm going to show you a video over the next couple of days about you can form plasma in your microwave. It's pretty cool. So if we talk about a solid in particular, solids have a fixed shape and volume. We call it a special word in chemistry. We say that most ionic compounds, we'll talk about this later, form what we call a lattice structure. And that lattice structure is very fixed. I'll show you an example in class, but those atoms, they can't move about that fixed position. They're very fixed. If you break that fixed position, then you can actually turn it into a liquid, or you'd actually just shear off some atoms from that structure. Again, a liquid, I'm not going to read all of this, but a liquid, again, it's farther apart. The atoms are farther apart than a solid. And they have a constant volume, but they take up the shape of the container. And finally, we have a gas. And again, it has a variable shape and variable volume. It can change. There's large distance between these atoms and particles. The way that we're going to think about gas particles in this course is that they're a bunch of bouncy balls bouncing off each other, not losing speed in we call them perfectly elastic collisions. So let's continue on with our review. Let's talk about the difference between an atom and an element. Well, an atom is the smallest unit of an element that maintains the properties of that element. That might seem a little bit abstract to you, but let's talk about what an element is. An element is a pure substance made of only one kind of atom. So when we talk about elemental gold, what we mean is that we have like a bar of gold. And if we break down that bar of gold into its smallest and tiniest pieces, we'd find out that it's an atom. Now the periodic table is all the elements that exist in our universe. These ones down here are actually very large. The ones at the top and to the left are actually very, very small atoms. A compound is a combination of elements, okay? It's a substance that is made from two or more different elements that are bonded together chemically. Now there's two types of bonds that we're going to talk about in this course, actually three. There's covalent and ionic. Those are the ones that we think of immediately, but there's also a metallic bond. And we'll discuss that one as well in this course. They are a pure substance. So for example, sucrose. This is table sugar. If anybody ate sugar this morning for breakfast, this is what you ate. This is common table sugar. It contains 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms that are chemically bonded together in a covalent bond. This is what it looks like if we zoomed in on it. It's a three-dimensional representation. And sucrose is, again, it's that substance that we use to make gummy bears and other candy that you have. So again, just to reiterate, compounds are a combination of two or more elements in definite ratios. For example, the compound water, for every 2 hydrogens, there is 1 oxygen. Okay, we don't show the 1, that's why it's just H2O. Okay, but essentially it's a 2-to-1 ratio. So the character of each element is lost when forming the compound. Now we drink water, obviously. Water is made up of hydrogen gas, which is explosive, and oxygen, which increases things burning. Essentially, it's what causes burning or oxidation. And they're both sort of reactive, but when we combine them together, we get something that we can drink, okay, when they're both sort of explosive. So the characteristics of the hydrogen gas and the oxygen gas is lost when we combine them together to form water. So if we take water, element, or a compound water, that means we have many waters, okay, like billions, trillions of water molecules. And that's what we consider a compound of water. And now, if we take the smallest unit of a compound that retains the characteristic of a compound, that's just one water. And that's what we call molecule, okay? So essentially, if you break down the smallest unit of a compound is a molecule. So when we write down the molecular formulas for molecules, for example, glycine, this formula is C2H5N1O2. Now this can tell us some interesting information. It tells us how many atoms exist in this. So if you count with me, just take a moment and count how many atoms. How many carbons should I have? How many hydrogen should I have? How many nitrogen? How many oxygen? If you do it correctly, you'll find out that you have 5 hydrogens, 1 nitrogen, 2 carbons, and 2 oxygens. So when we talk about the properties of the matter, we can define it in several different ways. One way that we can define the properties of matter is in terms of quantitative and qualitative properties. Now quantitative, the root word of this is really quantity. And I remember that as number. So when we talk about quantitative properties, what we're talking about is things that require the use of a measurement. For example, if we wanted to define matter in terms of melting point, boiling point, or density, all these require numbers. This would be a density number. Boiling point might be for water, it's 100 degrees Celsius. Melting point is 0 degrees Celsius. They all require a number, so they are quantitative properties. Qualitative properties are just the opposite of that. They do not require the use of a measurement or a number. For example, state. Water is a liquid. That is a qualitative property. The color of water is clear or blue depending, and that is a qualitative property as well. Or if you're describing the texture, you're using words, not numbers. They're qualitative properties. Another thing that we can define is something called physical versus chemical properties. Now, physical properties, these are the characteristics of a substance which can be observed with the senses. For example, state, color, odor. So if you're talking about like a piece of paper, it's white. It does not have an odor. It's a solid state. That's a physical property of a piece of paper. If you want to talk about, properties of matter in terms of chemical properties, it's a little bit more complicated. And these describe the characteristics of chemical changes a substance can undergo. So this means that, like for example, a piece of paper will burn, will react with oxygen, and will burn. So any chemical properties of an object, any chemical reactions that it can undergo are considered to be chemical properties. So like physical property and chemical property, we also have something called physical change and chemical change. And the difference is a physical change, if you remember, is a change in a substance that does not involve a change of the identity of the substance. So when we think about this, the key word here is identity for us. So it will not change the substance. The substance will remain the same. It's like boiling water, going from liquid water to gas or liquid vapor. Some examples of physical change would be like changes of state, like there's a couple different ones, like evaporation, solidification, and so on. Also cutting something into smaller pieces, like a piece of paper, cut it up into smaller pieces. What kind of change is that? It's a physical change because it's still paper. So some physical changes would be boiling of a liquid, melting of a solid, or dissolving a solid in a liquid to give a homogeneous mixture. So taking some salt, putting in water, that is a homogeneous mixture. That is an example of a physical change. These are the examples of changes as well. You should remember this from grade 8 maybe. I don't know, guys. It was a long time ago. But so you have solid to a gas, that's sublimation. That's kind of a key one to know. And you have melting, freezing, vaporization or evaporation, and condensation. So you should remember those from grade 8. A chemical change is the other type of change that's not physical. And what happens is a change in which one or more of the substances are converted into different substances. So you actually have a change in the chemicals that are in the substance. So for example, we know that this happens if you have heat or light given off. So the 4 signs that you have are a new precipitate is being formed, you have a color change, gas or bubbles are formed, or heat or light is formed. And the key thing to know here is that this is irreversible. So you have, this is the first one, second one, third one, fourth one, and you also have a 5th, which is irreversible. Okay? I don't know why I did that there. So irreversible is the last one. Ooh, it's not. Anyways, you guys get the idea. Irreversible. There you go. So, again, chemical properties and chemical change. So the difference between a chemical property and a chemical change, this is an example of a chemical property. If you burn hydrogen, so hydrogen burns in oxygen to give water. Okay, that is an example of a property. A change would be involves the transformation of one or more atoms into one or more different molecules. That's an example of a chemical change. Recall as well from grade 10, matter can be classified into 2 groups. You have mixtures or pure substances. Mixtures can be further divided into homogeneous mixtures or heterogeneous mixtures. And pure substances can be divided into compounds or elements. Now remember, elements can be, the smallest element is an example of an atom. The smallest compound is a molecule. Okay? Heterogeneous mixture would be example, like I have a few examples here. I always think of like a chocolate chip cookie because you can see the chocolate bits, you can see the cookie parts. That's a good example of a heterogeneous mixture. And homogeneous mixture is a mixture where you can, it's like one phase. And what I mean by that is you can't see the difference between the different parts, like sugar water. You can't see the difference between, you can't see the sugar, you can't see the water. Whereas a cookie, it has two phases. You can see the chocolate chip part, and you can see the normal cookie. So one thing you may have not learned in grade 10 is how to separate a mixture, okay? And there's a bunch of different ways that we can do this, but the mixture, basically a mixture, it can be separated by physical means because it's made up of different things, okay? Because it's made up of different sizes here, different pieces, and so those different things have different characteristics, and so you can separate those things based upon those characteristics. For example, this is some chromatography paper, and what you do is, I used this previously in my previous profession, is you would take a little sample of your substance, you put it along here, and over time the substance will move up the paper, okay? And you can see that this actually represents about 3 different chemicals that are being separated along this paper. So one way you can separate mixtures is using paper chromatography, okay? That's one way we can do it. Another way we can separate mixtures is through distillation. And right down the road from Walkerville, we have Hiram Walkers, and they do this all the time. So in here you'll have your alcohol, and you have your water mixture, and it's about 5%. And so what happens is when you heat it up, alcohol has a lower boiling point than water does, so it evaporates more than the water will. So up here in this tube, after you heat up your alcohol water solution, you get more alcohol vapor. As it goes down this tube, it gets condensed by cold water. Cold water flows through this, it cools down the vapors. Have you ever heard of alcohol being referred to as spirits? This is why, because it's actually, it's a vapor at this point. And as it condenses, it just gets collected. And as you go through this distillation process, this will end up having more alcohol in it over time. So I don't want to talk about alcohol too much here, guys, but if you ever heard of triple distillation, some vodka is triple distilled, and that means they do this process over and over again. So they take this substance here with more alcohol, they put it back here, they heat it up, more alcohol evaporates, goes down the tube, and then your distillate ends up having a higher concentration of alcohol over time. If you do that enough, you can end up with just leaving your water here and transferring your alcohol. So that's a way we can separate a mixture, specifically a solution like an alcohol water solution. The way that you can separate water is by adding electricity to it. So if you take water, H2O, and we add electricity to it, what will happen is it will break down into hydrogen and oxygen. So again, if you want to balance this, if you remember how to balance, oops, I don't think I remember how to balance here. There we go. So that's 2, 2, 1. But anyways, the point is that if you add electricity, you can break down certain compounds into elements. So here we have a compound, and here we have an element. So this is a way we can separate compounds. So all compounds must be separated by chemical means. They cannot be separated by physical means, okay? They have to be separated by chemical means. So if you want to break down a compound, it has to be through chemistry. If you want to break down a mixture, you can break it down by physical means. And that means things like filtering and so on. We'll explore these in class. So let's just quickly talk about our modern atom. Let's just review a little bit about the atom. We did this a few lessons ago. First thing we want to know is that it's very, very small. And again, when you're neutral, you have equal number of protons as electrons. In your nucleus, you have protons and neutrons. Around it, you have an electron cloud or shells. Again, if you want to talk about, I use a school analogy, but if you want to talk about a sports stadium analogy, in the center you have your nucleus. It might be like a golf ball, and the electrons would be flying around on the outside. So it's mostly empty space, and all the mass is located in the center. Again, quickly, you should remember this, and this should not be a surprise to you. Proton has a +1 charge. All the mass is in the protons and the neutrons. They weigh the same. They're located in the nucleus. Neutron has no charge. An electron has a -1 charge, has no weight, and is located in shell. This is something new to you. Isotopic notation, all that is the mass number is located at the top, and the atomic number is located at the bottom. So for example, if you look at your periodic table, you'll find that the element, for example, lithium, has an atomic mass of 6.9. So it's an atomic mass of 6.9. So we could actually put that up there. And we also say that the atomic number is 3. So again, the smaller number is always the atomic number. The bigger number is always the atomic mass number. Now we also remember that we want to round. And we'll explain why we have to round right now. So again, so actually just give me a moment here. So we know the atomic mass is 7, atomic number is 3. To find the number of protons, all you have to do is subtract the two numbers. So in this case for lithium, it has 3 protons. When it's neutral, it has 3 electrons. And to find the number of neutrons, you just subtract, and the answer is 4. The last thing we're going to discuss is isotopes. Now isotopes are atoms with the same number of protons but a different number of neutrons. So atoms of the same element have the same atomic number with different mass number. So if you take a look at all the chlorines that exist in the world, what you'll find is that most chlorines will weigh 35, okay? And every once in a while you come across a chlorine atom that weighs 37. So look at the periodic table and you'll find out the atomic mass is equal to 35.45. Okay, now where does this number come from? I mean, this number here, 35.45, is not 35 exactly, and it's not 37. You can never have an atom that has 0.45 of a proton or 0.45 of a neutron. So this number, where's this number coming from? Well, as it turns out, it's actually an average atomic mass. It's the average weighted mass of all the naturally occurring isotopes of an element. So that 35.45 we were looking at before, it means that there's actually more 35 isotopes than there is 37. So it works out to an average. If you take a random sample of chlorine, then on average, between all the 35 and 37 isotopes, it will weigh 35.45. If you look at this sodium number here comes at 22.99. So we can assume that the most common isotope will actually weigh 23. So again, the protons and the electrons are not impacted with isotopes. The only thing that's impacted is the amount of neutrons. So that's the end of this lesson. I hope this review was helpful for you. And please post if you have any questions.